this video will cover the steps to find the inverse of a function algebraically. So at this point, we have covered how to find an inverse graphically, right? You check the points, and then you interchange the x and y. And so the process of interchanging x and y, we could also refer to that as the numerically process of finding the inverse, right? And we all know that inverse functions are reflected across a line. So let's just write that down. Inverse functions are reflected across the line y equals x. And do you guys remember how we call that line? It has a special name.
The y-axis?
Linear. It is the parent function of linear functions, but we also refer to it as the identity function. And we call it that because the input is the same as the output, right? Like if x equals 1, y is equal to 1. If x is 2, y is equal to 2. So what we're going to do now is list the steps to find the inverse of a function. And so number 1 is going to be replace f of x with y. And remember, we established from the beginning of the semester that function notation represents f of x. In this case, we could use any other letter like g of x, h of x, k of x, m of x. But that is just given to the output, in other words, to the y value, right? Now, number 2, we're going to interchange x and y. So do you guys remember how when we were finding the inverse of a function numerically, we were interchanging the x and y values, right? And you did that several times from a table of values. So that will be the next step, step number 2. And we were going to do several examples, don't worry. So now let's go to number 3, and that will be to solve for y. So what that means is we're going to isolate y, which means that you're going to leave y by itself. Okay, after we do that, we'll go to number 4, and number 4 will be to replace y with the notation, function notation for an inverse of a function, and that will be f inverse of x. Are you taking notes? Okay. So those 4 steps are very important, and let me go ahead and do an example. And so we're going to start with the first example of your paper title function inverses, this one. And so is it that one? Or is it inverses of linear functions? Which one did I do? Function inverse. Okay. All right. So we could take the inverse. We could find the inverse of any function, not necessarily linear. But let's start with an example of a linear function. Okay. So I want to look at example number 9. So the equation for that is, it says h of x is equal to the cube root of x minus 3. So we go to step number 1. Now, I know we don't have f of x, but we have h of x instead, okay? So by step number 1, we replace h of x with y. Now, the next thing, step number 2, it tells me to interchange x and y. So what I'm going to do, I'm not going to solve for x, solve for y at this point. I will simply replace the y with x, and x replace it with y. That's it. That's all we do. We don't change them to the opposite side. We just replace one with the other. Now this negative 3 is still here. And now what we do next, I'm going to make some room here. So what we do next is we solve for y. And that is step number 3, solve for y. So what I need to do first is, you guys notice here's a minus 3, right? Subtracting the cube root of y. So what I need to do here is the inverse operation. So I will be adding 3 to both sides. Or what I like to say is we take this negative 3 across. That would change it to the inverse operation. So now the negative 3 will be adding to the x. Now we're almost done. We just need to do one thing. How can we undo a cube root? By what? Multiplying by what? So if it was a square root, how could you undo it? You square it. So if we have a cube root, we square that. Now whatever we do to one side, oh, I'm sorry, not square but cube. That should be cube. So that will cancel with that, and whatever we do to one side, we need to do it to the other side. So now the cube root, once we raise that expression to the third power, will cancel, and we just have y by itself. Remember, that was the purpose, to isolate y. And that means we are done. Now, step number 4, it says here, replace y with function notation for f inverse. So instead of this y, I will write down f inverse. Actually, we did not start with f, right? What was the letter we used for this function? H, from here. So instead of using f inverse, we will use h inverse of x, and that is equal to x plus 3 to the third power. And that's it. We are done. Now, what we're going to do in a minute, we're going to get calculators, and then we could verify if you did your steps correctly by graphing both at the same time and seeing that reflection across the y equals x axis, line. All right, so this is the end of the video, and, well, we might do a couple of more examples. Okay, we're going to do one more example. In this case, I want to take example number 10. Problem number 10 from your handout. And so we have the function g of x is equal to 1 over x minus 2. And we're going to follow the steps. So step number 1, it says to replace f of x. In this case, we don't have f of x. Instead of that, we have g of x, so we're going to replace that with y. Step number 2. What was step number 2, Alvin?
Interchange x and y.
Interchange x and y. So this y becomes x, and the x becomes y. That's simple. Now from here, step number 3, what would that be? Solve for y. So in this case, we have this negative 2. What is that negative 2 doing to the 1 over y? It has a minus. So it is subtracting, so once I take it across, it's going to change to addition. Now we're almost there, but we still need to solve for y, right? What can we do there? Multiply by what? Well, if we multiply by 1, we will not be changing anything to it. But let me ask you guys a question. What is this y doing to the 1? Dividing, right? So if I take it across, it's going to change to the inverse operation. And I think we all know what that is, right? Mm-hmm. What is the inverse operation of division?
Multiplication.
Multiplication. So that y will be multiplying here. And then, just to solve for y, what are the y and the x plus 2 inside parentheses doing to each other? No.
Multiplying.
Right here, the y and the stuff in parentheses multiplying, right? Because there's no sign in between. So we know they're multiplying. So what I'm going to do is take this whole expression, take it across, and from multiplying, it will be dividing. And we're almost done. That is the inverse. But we still need to follow with step number 4 that states replace y with the inverse notation. So we started with function g, so we will call this one g inverse of x is equal to 1 over x plus 2. Okay, so here are the steps for problem 11. We had h of x is equal to 2x cubed plus 3. First step is to replace h of x with y. Then we interchange x and y, so the y becomes x and the x becomes y. After that, step number 3 is to solve for y. And so we had a plus 3 here, we moved it across, it became negative 3. And then after that, we had 2 times y cubed. So since the 2 is multiplied to the y, we moved that across, and that was dividing. After that, we had y to the 3rd power here, and so the way to undo that is to take the cube root. So the cube root cancels with the 3rd power, and here we have the cube root, because whatever we do to one side, we have to do it to the other side. So that will be the answer for problem number 11. Now I'm going to write problem number 12, and you could also verify your answer. So we have a function called g of x is equal to negative 4x plus 1. So step number 1, replace g of x with y. Step number 2, interchange x and y. Step number 3 is to solve for y. So we have the plus 1 here, adding to the negative 4y. So if I take that across, it will be subtracting. So it will be x minus 1 equal to negative 4y. And now we know that the negative 4 is multiplying to the y because there's no sign in between. So if I take this negative 4 across, it will be doing the inverse operation, which is division. And keep in mind that we must divide by negative 4. Now, that is the correct answer. However, it might be beneficial if you simplify it a little bit more. So that would be x divided by negative 4, and then negative 1 divided by negative 4. And we do that because the negative 4 is dividing everything that is on the numerator. If I keep simplifying, I could say here that x divided by negative 4 is the same as negative 1/4 times x. And here I will have negative divided by negative, that will turn into positive 1/4. So this answer is correct, but this one becomes a little more handy when you are talking about what is the slope. Because here you could determine that the slope is equal to negative 1/4. And you could also determine that the y-intercept is the point at 0, 1/4. Now, just to finish the problem, that clock is ahead, so don't pack your things yet. To finish the problem, step number 4, we replace this y with the function notation, and so that will be g inverse of x is equal to negative 1/4 of x plus 1/4, and that is the final answer. Now, if you're not in class, for Friday, you will be required to work on that same packet, finish both sides of the paper, and turn it into the substitute on that day.